Today's lab is about extended distance planning and calculations. So we'll start first of all with planning, and in particular the role of the planning therapist in setting up the field and the plans for the doctor, for the physician, so that they can plan this in as most efficient manner possible. So a couple of things to remember. Typically we treat it at 100 centimeters SAD, and our extended distance technique is a variation on that, where we're still SAD, but we just extend the distances out. Remember that the maximum jaw setting for X1, X2, Y1, Y2 is 20, so your maximum field length or width is 40. So extending out your SAD allows you to treat bigger areas, or larger, longer, wider fields. So at 110 you can go up to 44, at 120 you can go to 48, and at 130 you can go to 252. We don't really recommend you go to 140 because it creates technical issues for delivering treatment. As well, because we standardly treat with SAD techniques, when we extend our beams, we have to ungroup the fields, and each field will have its own isocenter. What that means is you won't actually see an isocenter in the patient anymore. So what we've decided as a program is we're going to create a reference point and name it SAD, and then the number for the extended distance, so SAD 110, SAD 120, SAD 130, and that point, that reference point, will represent the isocenter in the patient if the software was designed to treat extended distance SAD techniques. So what I'm going to do here is we have a test patient where the plan is to map out an extended treatment to his left femur. We're going to do 120 centimeters SAD. So we'll walk you through what the planning therapist should do to get this ready for the physician. So here we go. So on the screen here I have a femoral plan. So currently we've assumed that planning is marked as per policy. We have a GA0 femoral field, and so we'll just walk through all the steps. So you'll notice here that currently we have a SSD of 92, and so the first thing you're going to want to do is just make a decision about where your isocenter is. If I enlarge the BEV here, you can see what anatomy is being covered at the distance, currently at the 100 centimeter SAD sort of technique, so at 92. So the first thing I'd recommend is if you're shooting for 120 centimeter SAD, let's extend the field out and just see what we get. So I'm 92 at 20 would give me 112. Now you can see I'm covering a bigger area. I'm going to assume that now that I've extended it out that I like the anatomical coverage I'm getting. So I'm going to take it back to 92. There we go. The next thing I'm going to do then is oppose the field. So I've got this GA0 over here. I'm going to go to new opposing field. The default is it'll name it field 1. I'm going to go into properties and rename that to GA180 FEML. And I'm going to rename the image as well while I'm at it. So I now have an opposed field. And just a reminder as well that what's somewhat unique to extended distance vert sims is that we have two reference points. So over here on the left, you'll see the reference point that we've named after the treatment site and the plan. So you'll have a femoral reference point, and then you have this second reference point, SAD 120, which, as you remember, is the reference point we've created as a placeholder for where the isocenter actually is in the patient. So I'm just creating that SAD 120 reference point that we're going to use as our surrogate isocenter. So I said the ID and name, SAD 120. I'm going to tie it to or link it to the patient volume of body. That's typically what we do. So I've got that there now, and it's what we need to tell it now is we've created the reference point. We need to give it a location. So I'm going to move the reference point to the isocenter. So the isocenter at 100, which is done now. Now I'm at a point where I can think about extending the fields out. So the first thing I want to do is make sure they're over on the left-hand side that the fields are ungrouped. That allows the fields to operate independently. Then I'm going to add 20 centimeters to each of my SSDs. Now in this case it's fairly straightforward because they're both 92, so 112. And I'm going to do the same to that posterior GA180 field, 112. And now what you'll see, I've got the 4-panel view in Eclipse, is you'll see that I have an opposed pair covering the left femur, and you'll see there are 2 isocenters in air. And that's because we've extended the fields out, but you'll also notice there's an SAD 120 reference point where the isocenter was when we were at 100 centimeters SAD. So basically this is pretty much ready to go for the doctor to actually plan. You'll have to remind the doctor that they have to plan the fields almost like independently of each other. So they'll set their MLC layer on the GA0. They'll have to conversely do the same thing on the GA180 field. As well, remind the doctors that they cannot and should not, more they should not, do an isocenter shift, because what will happen then is if they shift the isocenter, you'll know right away when you get the plan back from them, because you'll see that the SAD reference point you created is no longer in the same plane as the machine isocenter, the treatment isocenter. So the SAD 120 reference point should line up with the isocenter. If it doesn't, it means the physician has moved the plan on you, and then you have the issue of you can't be sure that you're still mid-plane if they've moved the isocenter to okay, we're going to pick up the process now from the point whereby the doctor has plan approved the plan, so they've set their MLC, they like the anatomical coverage, they plan approved it, and now you're in the calc room and you've got to deal with this extended distance calc. So remember, the first calc is done using the RT Calc spreadsheet. So it's pretty much preset what you need to enter, and so I won't go over that in this video. But if you're the second calculation person, you're going to need to use the formula and do a hand calc, and this is what we want to review with the balance of this video. So I'll just remind you of the formula over here. So our dose, to calculate a dose for that, we'll use the reference dose times the TPR, and that's for the field size. And then we'll multiply that by the ROF, which is the collimator setting, times the peak scatter factor. And again, we're going to use field size data for that. And then we also need to do an inverse square law correction. So we'll go over where we get all these values from. So the first thing to be aware of is, of course, when we extend a field, so our maximum field size at 100 is 40 by 40. But once you pull the field out, the concept of similar triangles comes into play. So over here you'll see, what my diagram is meant to show is the normal geometry. If your source is here, you go 100 centimeters away, your x1, x2, y1, y2 jaw can only go as far as 20 out. So if you go to 120 centimeters, so an extended distance, we need to know what this distance would be. So basically, it's just a ratio based on similar triangles. So 20 to 100 equals x to 120. There's the formula. 20 over 100 equals x over 120. When you multiply that out, you get x equals 20 times 120 over 100, and that works out to 24. So at 120 SAD, your maximum field size actually works out to 48. Oh, so why does that matter? Well, that matters because if you remember in the formula, we look up some values using a field size and some values using a collimator setting. So your ROF is a collimator setting value. Your TPRs and your peak scatter factors are based on field settings. And some of those variables, as you remember, you're actually going to look up and you're going to calculate an equivalent square using the appropriate numbers. So an equivalent square for your TPR from your field size, your equivalent square for your PSF is from your field size. Your ROF, you're just going to look up your collimator settings. So whatever your jaw settings are in Eclipse are going to be this number. These are going to be based on what you've calculated using similar triangles. So we'll walk through this again. So your final dose rate, your reference dose rate for the machines, they're all calibrated, is 1. Your TPR, again, you're going to look up that field size. So at 120, it might be, you'll have to calculate your equivalent square using the field size you've calculated using that similar triangle formula. Your ROF will be your collimator settings, so the X and Y values contained in Eclipse. Your peak scatter factor will be, you'll look up from the graph in the data books, and that's based on equivalent square calculated from the field size. And then last but not least, you'll multiply that by your inverse square law correction. And again, for 120 SAD, remember your inverse square law correction will be 100 centimeters over that distance, in this case 120, and that will give you a factor. Remember, all these variables are available online, and the Medical Physics has a data book, and they will have this table, this is a graph, and you calculate this.